There is a particular quality to the silence that arrives just after midnight, when the hum of the day has drained away and the air itself seems to settle into a deeper stillness. It is in that hour that some people find themselves drawn to windows, to doorways, to any opening that frames the sky. They stand there, not quite knowing what they are looking for, aware only of a pull that has no name. The stars overhead do not shout. They do not announce themselves with fanfare or demand attention. They simply persist, scattered across the black like questions written in a language we have not yet fully learned to read. For most of human history, we have looked up and wondered whether anything looks back. We have asked if the universe notices us, if it holds any awareness of our small lives unfolding on this single blue stone circling an ordinary star. The dominant answer for a long time was silence. We were told that space is a void, an emptiness punctuated by distant fires that burn without purpose, without connection to our hopes or sorrows. We were taught that the cosmos is indifferent, that it does not speak, does not respond, does not care. But what if we have been listening for the wrong kind of answer? What if the universe does not speak in words or thunder, but in whispers so faint that only patience and attention can catch them? What if its responses are not declarations, but echoes, not commands, but invitations? There is a growing sense, among those who study the night with instruments and intention, that the cosmos is not as silent as we once believed. It hums, it murmurs, it leaves traces and clues in the fabric of space itself, in the wash of ancient light, in the bending of paths we thought were straight. These are not messages written for us, perhaps, but they are messages nonetheless, and we have learned to catch a few of them as they drift past. This is not a story about equations or distant theories meant only for specialists. It is a story about listening. It is about the slow realization that the universe, in its own vast and patient way, might be answering us all along. Not in the way a person answers a question, but in the way a landscape answers a footstep, in the way an ocean answers a thrown stone with rings that spread farther than the eye can follow. The cosmos responds by being what it is, by moving as it moves, by leaving behind evidence of every event that has ever unfolded in its depths. And when we turn our attention toward it with care, when we watch and measure and listen with tools delicate enough to catch the faintest tremor, we begin to hear something. It is a strange and humbling thing to realize that the silence we feared might not be silence at all, but simply a conversation conducted in a register we had not thought to tune into. The stars do not call out our names, but they send light across distances so immense that the mind falters trying to hold them. That light carries information, carries memory, carries the signature of events that happened long before any human hand ever pointed upward. And when it reaches us, when it falls into our instruments and our eyes, it completes a journey that began in violence, in fire, in the quiet death of something far away. That is a kind of answer. That is the universe whispering back. So we begin here in the room of quiet answers, where the night is not an absence but a presence, where the sky is not empty but full of signals waiting to be heard. We begin by setting aside the idea that speaking and listening must happen on human terms, and we open ourselves to the possibility that a conversation has been unfolding all along, patient and enormous and utterly indifferent to our schedules or expectations. The universe does not wait for us to be ready. It simply continues, and if we are very still, very attentive, we might catch the edge of its voice. And perhaps if you find yourself drawn to this mystery, if the idea of a cosmos that whispers feels like something you have always suspected but never quite named, then you might consider staying close to this conversation. There are others who listen too, who gather the faint signals and turn them into understanding. If you would like to hear more of what the night has to say, subscribe and join those who choose to pay attention. Because the universe speaks whether we listen or not, but the listening, when it happens, changes everything. The question is no longer whether the universe is silent. The question is whether we are willing to hear what it has been saying all along. We are told that space is empty, and in a sense, that is true. Between the stars, there is almost nothing. No air, no sound, no medium to carry a shout or a song. If you could somehow find yourself suspended in the void, far from any sun, you would experience a silence more complete than anything available on Earth. There would be no rustle of wind, no hum of distant engines, no crack of breaking ice or murmur of water. You would be surrounded by an absence so total that it might feel like the universe had simply stopped. But emptiness is not the same as silence, and the void is not quite as void as it appears. Even in the darkest reaches, in the spaces between galaxies where the light of stars cannot reach, there is something stirring. There is motion at scales so small that they slip beneath the notice of our senses, fluctuations that ripple through the fabric of space itself, never settling into perfect stillness. This is not the hum of machinery or the vibration of a struck bell. It is something stranger, something fundamental to the way reality is stitched together. It is the universe flickering. At the smallest scales, the ones that quantum physics tries to map, space is not smooth. It is not a blank stage on which events unfold. Instead, it is alive with tiny eruptions, with particles that appear and vanish in the span of time so brief that calling it a moment would be generous. These are not permanent things. They do not last long enough to be measured directly, but their effects accumulate, leaving a faint background hum that suffuses everything. It is as if the universe, even in its quietest corners, cannot help but tremble. This is not silence. It is a kind of whisper at the foundation of existence, a restless murmur that has no beginning and no end. If you could listen with instruments sensitive enough, you would find that the vacuum is not a vacuum at all, but a sea of potential, constantly on the edge of becoming something, and then collapsing back into itself. It is the sound of nothing trying to be something, over and over, in an endless loop that plays out across every cubic inch of the cosmos. And then there are the other echoes, the ones left behind by events that happened so long ago that their sources have long since faded. When the universe was younger, when it was hot and dense and everything was pressed together in a state of almost unimaginable violence, it made noise. Not sound in the way we understand it, but pressure waves that traveled through the primordial plasma, compressing and expanding the fabric of space itself. Those waves have long since passed, but their memory remains, imprinted on the background of everything that came after. We can still detect them, if we know where to look, faint compressions and rarefactions in the light that reaches us from the edge of the observable universe. These are not messages in any intentional sense. The universe did not set out to tell us anything, but they are answers nonetheless, responses to the question of what happened when everything began. They are echoes of a moment that predates stars, that predates matter as we know it, bouncing through the ages until they finally reach us, faint and distorted but still legible. They tell us that the universe was not born in silence. It was born in a roar, and even now, billions of years later, we can still hear the fading edge of that sound. There are also the small tremors that arise from objects we know exist but cannot see. Dark matter, whatever it is, does not interact with light, does not shine or reflect or absorb. It passes through space like a ghost, detectable only by the way it tugs on things that do shine. But that tugging is itself a kind of echo, a gravitational whisper that says something massive is here, something that matters even if it refuses to announce itself in any conventional way. We have learned to map its presence by watching how galaxies move, how light bends around clusters we cannot see, how the motions of visible things hint at invisible hands guiding them. And then there are the currents, the slow drifts of gas and dust that move through the space between stars, stirred by ancient explosions and the pressure of light itself. These currents do not make sound, but they leave signatures in the way they glow, in the way they block or scatter the light from objects behind them. They are the breath of the galaxy, slow and vast, circulating matter that was once locked inside stars and is now free to wander, to cool, to eventually collapse again into new fires. This too is an echo, a response to events that ended long ago, a way the universe carries forward the consequences of every supernova, every collision, every moment of creation or destruction. Even the fields that permeate space, the ones that give particles their mass and govern the way forces operate, are not still. They fluctuate. They respond to the presence of matter and energy, bending and flexing in ways that cascade through the surrounding space. When a star collapses, when a black hole devours something too close, when particles collide at energies high enough to tear the fabric of normal interactions, these fields ring like struck gongs, sending ripples outward that we can, in some cases, detect. They are faint, often overwhelmed by other signals, but they are there, persistent reminders that nothing in the universe is truly at rest. So the void is not empty, and space is not silent. It is filled with echoes, with the aftershocks of a billion events playing out across scales we can barely comprehend. Some of these signals are so faint that it takes decades of observation to tease them out from the noise. Others are louder, more insistent, but still require careful listening to understand. And all of them, taken together, form a kind of background hum, a texture to the universe that tells us it is not a dead thing, not a static backdrop, but something dynamic and responsive, something that carries memory and consequence in every fold of its structure. To listen to these echoes is to become aware of just how much is happening in places we once thought were barren. It is to realize that the universe is never quite still, never quite silent, even when it seems that nothing is moving. There is always a flicker, always a tremor, always the faint trace of something that happened elsewhere, elsewhen, leaving its mark on the present. And if we are patient, if we build instruments sensitive enough and train our attention carefully enough, we can catch these whispers and begin to assemble them into something like understanding. The cosmos does not speak in sentences, but it speaks nonetheless. It murmurs in frequencies we have only recently learned to detect, in patterns that reveal themselves only after years of watching. And every time we catch one of these faint signals, every time we pull a new echo out of the noise, we are reminded that the universe is not a place where things happen and then vanish without a trace. It is a place where everything leaves a mark, where every event ripples outward, where the past is always present in some subtle, persistent way. The universe hums, and in that hum there is memory. Light does not hurry, but it does not stop either. Once it begins its journey, it continues, crossing distances that would take human lifetimes to even name, moving through space at a speed that feels both impossibly fast and, given the scale of the cosmos, almost painfully slow. Every photon that reaches us from a distant star is a traveler, something that has spent years, centuries, millennia in transit, carrying with it the memory of where it began. By the time it arrives, the star that sent it may have changed, may have aged, may have died, but the light continues, indifferent to the fate of its source, arriving long after the moment has passed. This is what makes starlight strange. It is not a signal sent to us, not a message crafted with intention, but it is a message nonetheless. It is evidence, testimony, a record of something that happened far away and long ago. When we look up at the night sky, we are not seeing the present. We are seeing the past, a layered archive of moments preserved in the light that finally reaches our eyes. The farther we look, the deeper into history we see, until at the very edge of what our instruments can detect, we are looking at light that has been traveling for most of the age of the universe itself. It is like receiving letters written before we were born, before anyone we know was born, letters that have crossed an ocean so vast that the mind cannot hold it. And like letters, starlight carries information. It is not blank or featureless. Every photon is shaped by its journey, by the conditions it encountered along the way, by the nature of the object that released it. When a star burns, it does not emit a uniform glow. Its light is a spectrum, a spread of colors that reveals the elements present in its atmosphere, the temperature of its surface, the speed at which it is moving toward or away from us. We have learned to read these spectra the way a musician reads a score, translating the pattern of lines and gaps into knowledge about the composition and behavior of objects we will never touch. Some stars are rushing away from us, their light stretched into redder hues by the expansion of space itself. Others are moving closer, their light compressed toward the blue. Some are young, their spectra dominated by the signatures of hydrogen and helium, the raw materials from which everything else is built. Others are old, enriched with carbon and oxygen and iron, elements forged in earlier generations of stars and scattered into space when those stars died. Every spectrum is a fingerprint, a unique signature that tells us not just what the star is, but what it has been, what processes have shaped it, what history it carries. And then there are the interruptions, the moments when starlight passes through something on its way to us. If a cloud of gas drifts between a star and Earth, it will absorb certain wavelengths, leaving dark lines in the spectrum where bright ones should be. Those lines tell us what the cloud is made of, how dense it is, how fast it is moving. If the light passes near a massive object, it will bend, its path curved by the gravity of something we might not be able to see directly. That bending is itself a message, a way the universe reveals the presence of things that do not shine. We have found planets this way, detected black holes this way, mapped the distribution of invisible matter by watching how it warps the light from galaxies behind it. Starlight also carries the signature of violence. When a massive star dies, it does not fade quietly. It explodes, releasing in a single moment more energy than it emitted over its entire lifetime. The light from that explosion races outward in all directions, a sudden flare that can, for a brief time, outshine an entire galaxy. That light reaches us as an announcement, a signal that something catastrophic has happened somewhere far away. By the time we see it, the explosion is over. The shockwave has already torn through the surrounding space, but the light preserves the moment, allows us to study it, to measure the energy released, to understand the physics of collapse and rebirth. And sometimes the light does not come from a star at all, but from the space around objects so dense that they tear the fabric of reality. Near a black hole, light can orbit, can be pulled into spirals, can be stretched and distorted until it barely resembles the signal that began the journey. We have imaged these regions, seen the glow of matter falling inward, seen the way the black hole's gravity bends everything around it into strange, warped shapes. The light that escapes carries the story of that warping, tells us how strong the gravity is, how fast the matter is moving, how close it came to the point of no return. In this way, starlight is not just illumination. It is communication, a continuous stream of information that flows from every object in the universe to every other object, crossing the dark in straight lines or bent paths, arriving at our eyes and our instruments as evidence of things we could never witness directly. We are not there when a star is born, when a planet forms, when a galaxy collides with another. But the light from those events eventually reaches us, and if we are watching, if we have built the tools to catch and decode it, we can reconstruct what happened. We can see the past, not as memory, but as something still arriving, still unfolding in the present moment. There is something profoundly moving about this. It means that nothing is ever truly lost. Every moment of light emitted by every star, every explosion, every quiet glow from a cooling ember somewhere in the dark, all of it is still traveling, still carrying its message outward. Some of that light will never encounter anything. It will cross the voids between galaxies, pass through regions where nothing exists to catch it, and continue until the universe itself grows too cold and too diffused to sustain any structure at all. But some of it will find a receiver, a telescope, an eye, and in that moment of reception, the past and present will touch. We are awash in these messages. Every second, countless photons from countless sources strike the Earth, each one a tiny ambassador from somewhere else, some other time. Most pass unnoticed. They hit the ground, are absorbed by oceans, scatter in the atmosphere, and their stories are lost. But some reach instruments designed to listen, and those instruments translate the light into data, into images, into understanding. They show us galaxies so distant that the light left them when the universe was a fraction of its current age. They show us stars that died before the sun was born. They show us the slow waltz of planets around other suns, the flash of distant storms, the glow of gas clouds collapsing under their own weight to form the next generation of stars. And all of this is written in light, in the most basic and universal language the cosmos possesses. Light does not care about borders or languages or the limitations of human understanding. It simply travels, and in traveling, it carries the universe's response to the question of what is out there. The answer is everything. Everything that has ever glowed, ever burned, ever reflected or emitted even a single photon is announcing itself constantly in every direction. We are surrounded by messages, by letters that have crossed the dark sea, and if we take the time to read them, they tell us that the universe is not silent, not empty, not indifferent. It is speaking always in starlight. There is a warmth to the universe that does not belong to any star. It is faint, almost imperceptible, a glow that fills every corner of space and has no single source. If you could see in the right frequencies, if your eyes were sensitive not to visible light but to longer wavelengths, to the microwaves that wash through the cosmos, you would notice it everywhere. It is not bright, it does not illuminate. But it is there, persistent and uniform, a soft afterglow that has been cooling for billions of years but has never quite faded away. This glow is not new. It is older than any star, older than any galaxy. It comes from a time when the universe was very young, when everything that exists now was compressed into a state of extraordinary heat and density. In that early epoch, matter and energy were so tightly bound that light could not travel freely. Photons would move a tiny distance before being absorbed or scattered by particles, over and over, trapped in a kind of luminous fog. The universe glowed, not with the light of stars, which did not yet exist, but with the light of its own heat, a brilliant and all-encompassing radiance. But as space expanded, as everything pulled apart, the universe cooled. Eventually, it reached a temperature low enough that atoms could form, that electrons could settle into orbit around nuclei without being immediately knocked free. When that happened, light was suddenly free to travel. The fog lifted, and the photons that had been trapped were released, streaming outward in all directions. That was the moment the universe became transparent, the moment the glow escaped and began its long journey through the expanding void. That light has been traveling ever since. It has stretched as space itself has stretched, its wavelength pulled longer and longer by the expansion, until what was once a fierce, visible glow has been redshifted into microwaves. This is the light we detect now, this ancient whisper, the oldest signal we can receive. It reaches us from every direction, a nearly perfect sphere of photons that were released when the universe was only a few 100,000 years old, when the first atoms were forming, and the stage was being set for everything that would come after. We call it the cosmic microwave background, though the name does not quite capture what it is. It is not background in the sense of something unimportant or incidental. It is the earliest message we can receive, the farthest we can see into the past with light. Beyond it, there is no light to catch, because before that moment, light could not travel freely. So this glow marks a boundary, a horizon beyond which our view is blocked not by distance, but by the nature of the universe itself. And yet, even though it is ancient, even though it has traveled for most of the age of the cosmos to reach us, it is not perfectly smooth. When we map it with sensitive instruments, when we measure the temperature of the glow in different directions, we find tiny variations, fluctuations of only a few millionths of a degree. These are not random. They are the imprint of density variations in the early universe, regions that were slightly more or less dense than their surroundings. Those variations were the seeds of everything that came later, the places where matter would eventually clump together, where the first stars would form, where galaxies would assemble, where planets would coalesce, and on at least one of them, life would begin. So this faint glow is not just a relic. It is a blueprint, a map of the conditions from which the present universe emerged. It tells us how matter was distributed, how fast the universe was expanding, what the balance was between different forms of energy and substance. It tells us that the universe was not born uniform, that there were already differences, already structure beginning to take shape, even in that hot, dense state before anything we would recognize as an object existed. And it whispers. It does not shout its history, does not announce itself with obvious signals. You cannot see it with your eyes or hear it with your ears. You need instruments designed to detect microwaves, antennas pointed at empty patches of sky, receivers cooled to near absolute zero to filter out any interference. When you listen carefully, when you remove all the noise from nearby sources, from the sun and the galaxy and human technology, what remains is this faint, even hum, the thermal echo of a beginning that has never quite ended. It is strange to think that this glow has been traveling all this time, crossing unimaginable distances, passing through the formation and destruction of countless stars, witness to the entire history of the cosmos, and only now in this moment does it reach us. The photons we detect today have been en route for more than 13 billion years. They have seen nothing in a sense because they are light, and light does not experience time. But they have crossed everything, and in crossing, they have carried with them the signature of where they began. There is something deeply quiet about this signal. It does not vary much. It does not flash or pulse or change. It is simply there, a steady presence, a reminder that the universe has a memory, that the past is not gone but transformed, stretched, cooled, but still present in this faint and patient glow. To study it is to listen to the universe at its most fundamental, to hear the voice of a time before complexity, before stars and planets and the structures we navigate by. It is to touch, however indirectly, the moment when everything we know was just beginning. And perhaps that is what makes this signal so compelling. It is not a message sent to us, not a signal meant for anyone. It is simply the light of the early universe, continuing on its way, and we happen to be in its path. But in that happenstance, there is meaning, there is connection. It tells us where we come from, how the stage was set, what the initial conditions were that allowed galaxies to form, stars to ignite, planets to gather, and eventually, on at least one small world, for something like us to emerge and wonder about it all. The whispering background is not loud, but it is everywhere. It fills the space between stars, between galaxies, between us and the most distant objects we can see. It is the universe, still glowing faintly with the heat of its own birth, still cooling, still expanding, still carrying forward the consequences of that first moment. And if we are quiet, if we build our instruments carefully and point them with patience, we can catch that whisper, and in catching it, we can hear the universe saying, "This is where it began. This is what it was like. This is the warmth that has never fully gone away." Gravity does not shout. It does not emit light or sound or send out signals that can be caught by conventional instruments. It is a force that operates in silence, invisible, detectable only by the way it moves things, bends things, holds things together. And yet it is everywhere, woven into the structure of space itself, shaping the paths of everything from the smallest grain of dust to the largest galaxy. It is the universe's way of writing, and the script it leaves behind is subtle, elegant, and utterly pervasive. We think of gravity as a pull, as something that drags objects toward one another, but that is only part of the story. Gravity is also a geometry, a way that mass and energy curve the fabric of space and time. When something massive exists, it does not simply pull on nearby objects. It changes the shape of the space around it, warping the straight lines we imagine into curves, bending the paths that light and matter follow. This bending is not violent. It is smooth, continuous, a gentle reshaping that happens wherever mass is present, and it leaves traces we can read if we know how to look. One of the clearest examples is lensing. When light from a distant galaxy passes near a massive object, say a cluster of galaxies closer to us, the gravity of that cluster bends the light. The path the light takes is no longer straight. It curves around the mass, and from our perspective, the image of the distant galaxy is distorted, stretched, sometimes even multiplied, as light takes several different bent paths to reach us. This effect is not subtle. It is visible in images captured by powerful telescopes, arcs and rings of light wrapped around clusters, ghosts of galaxies that lie far beyond the cluster itself. This is gravity's handwriting, a signature left in the light that tells us something massive is present, even if we cannot see it directly. It is how we have mapped the distribution of dark matter, the invisible substance that does not shine but bends light all the same. By studying the way background galaxies are distorted, by measuring the arcs and the angles, we can infer the shape and mass of the lensing object, can trace the contours of structure that would otherwise remain hidden. It is a kind of shadow writing, where the presence of something is revealed not by what it emits, but by what it does to the light passing by. And gravity does more than bend light. It shapes the motion of everything. The way planets orbit stars, the way stars orbit the centers of galaxies, the way galaxies themselves move through clusters, all of this is choreographed by gravity. It is a slow dance, played out over millions and billions of years, with every object responding to the pull of every other object, the whole system evolving in a pattern that is both predictable and immensely complex. When we measure these motions, when we track the speed of a star as it swings around the galactic center, or watch the way a planet's orbit shifts over time, we are reading the handwriting of gravity, seeing the way mass inscribes itself on motion. There are also tides, the stretching and squeezing that happens when gravity is not uniform. Near a very massive object, the side closer to the mass experiences a stronger pull than the side farther away. This difference creates tension, stretching the object along one axis and compressing it along another. On Earth, we see this in the ocean tides, the way water rises and falls in response to the moon and the sun. But the same principle applies everywhere. Moons can be heated internally by tidal forces, their interiors flexed and kneaded by the gravity of the planet they orbit, generating enough heat to sustain subsurface oceans or drive volcanic activity. Stars can be torn apart by black holes in a process where tidal forces rip the star into a stream of gas that spirals inward, glowing brightly as it falls. This too is gravity's signature, written in the deformation and destruction of objects that venture too close to something massive. And then there are the ripples, the gravitational waves that Einstein predicted but humanity did not detect until recently. When massive objects accelerate, especially when they spiral toward one another and collide, they shake the fabric of space itself, sending out ripples that propagate at the speed of light. These ripples are extraordinarily faint by the time they reach us, stretching and compressing space by amounts smaller than the width of a proton. But we have built instruments sensitive enough to catch them, detectors that use laser beams bouncing between mirrors separated by kilometers to measure the tiny distortions as a wave passes through. When we detect a gravitational wave, we are hearing gravity itself, catching a vibration in the structure of space that was set off by something cataclysmic happening far away. It is the universe ringing like a struck bell, and the tone tells us what collided, how massive the objects were, how far away the event took place. We have heard black holes merging, neutron stars spiraling into one another, events so violent that they release more energy in a fraction of a second than all the stars in the observable universe emit in the same time. And we hear them not through light, not through any electromagnetic signal, but through the direct shaking of space, through the medium that holds everything else. This is perhaps the most intimate form of the universe's handwriting, a signal carried not by particles but by the geometry itself. It is a reminder that space is not empty, not passive, not simply a stage on which events unfold. It is an active participant, something that can be bent, stretched, rippled, and that carries information in the way it moves. Gravity writes on space the way wind writes on water, leaving patterns that reveal the presence of forces we cannot see directly but can infer from their effects. And everywhere we look, we find these patterns. The spiral arms of galaxies, shaped by the gravity of stars and gas pulling on one another as they orbit. The way galaxy clusters are distributed through the universe, tracing out vast filaments and voids, a cosmic web held together by gravity's patient pull. the orbits of exoplanets around distant stars, revealed by the tiny wobbles gravity induces in the star's motion, or the slight dimming when a planet passes in front of it. All of this is gravity, writing its presence into the structure and motion of everything. It is a quiet script, but it is everywhere. It does not need to announce itself because it is fundamental, woven so deeply into the way the universe operates that it shapes everything without exception. And when we learn to read that script, when we measure the bending of light, the motion of objects, the ripples in space, we are learning to see the universe's architecture, the way mass and energy arrange themselves, the way structure emerges from the smooth beginning and grows into the complex, tangled web of galaxies and stars and planets that we navigate today. Gravity does not speak in words, but it speaks nonetheless. It writes its presence in curves and spirals, in tides and lenses, in the slow drift of galaxies and the violent collision of black holes. And every time we catch one of these signals, every time we decode a new piece of the pattern, we are reminded that the universe is not silent. It is answering always in the language of curvature and motion, in the quiet handwriting of gravity. There are moments in the long and patient work of listening to the cosmos when something arrives that does not fit the pattern. A signal appears in the data, sharp and clear, but without explanation. It does not match the known signatures of stars or galaxies, does not correspond to any expected event. It is simply there, a pulse or a glow or a rhythm that teases the boundary between meaning and noise. And in those moments, the universe feels less like a place governed by orderly laws and more like a vast room filled with voices we do not yet recognize, some of them perhaps meaningless, some of them perhaps speaking in a language we have not learned. One of the most famous examples is the fast radio burst, or FRB. These are brief flashes of radio waves, lasting only milliseconds, that arrive from distant parts of the universe with no warning. The first one was discovered in archived data, years after it was recorded, a single spike in the signal that stood out so clearly it could not be dismissed as a glitch. But it was alone, unrepeated, and without context. No one knew what had caused it. No one knew if it would happen again. Over time, more were found. They appeared scattered across the sky, each one unique, each one arriving without any follow-up signal in other wavelengths. Some came from the same patch of sky, repeating on irregular schedules. Others were singular, one-time events that have never recurred. The energy involved is enormous, the kind of output that requires some violent or exotic process. But what process? Magnetars, perhaps, neutron stars with magnetic fields so strong they distort the structure of atoms. Or collisions, mergers, the death throes of something collapsing under its own gravity. It may be natural phenomena we have simply not encountered before, the universe operating at extremes we have not yet mapped. Or, and this is where speculation always creeps in, it may be something else. Every unexplained signal carries the shadow of that possibility, the faint and unlikely but never entirely absent chance that it is not natural, that it is deliberate, that someone or something else is out there, sending signals into the dark. We do not expect this to be true. The universe is vast and strange and full of processes we barely understand, and the most likely explanation for any mysterious signal is that it arises from some astrophysical mechanism we have not identified yet. But the possibility hovers, unspoken and persistent, a reminder that the universe is not fully known, that there are questions we have not answered, and that some signals simply do not fit. Then there are the oscillations, the periodic changes in brightness or frequency that some objects exhibit without clear cause. A star might dim and brighten on a regular schedule, but not in a way that matches the known behavior of pulsating stars or eclipsing binaries. A distant galaxy might emit bursts of radiation at intervals that seem too regular to be random, but do not correspond to any known orbital period or rotational rate. These patterns are tantalizing because patterns imply order, and order implies mechanism, and sometimes the mechanism is not obvious. we have learned to be cautious. Early in the history of radio astronomy, pulsars were discovered, objects that emit regular pulses of radio waves with such precise timing that the first ones were jokingly labeled LGM, for little green men. But the explanation turned out to be natural: rotating neutron stars with beams of radiation sweeping past Earth like a lighthouse. The regularity was not a message, but the consequence of rotation and magnetic fields and the physics of collapsed stars. It was exotic, yes, but not artificial. Yet the caution does not erase the curiosity. Every new signal that does not fit is an invitation to investigate, to consider possibilities, to ask whether we are missing something fundamental about the way the universe operates. And sometimes the answer is yes. Sometimes a strange signal leads to the discovery of a new type of object, a new process, a new window into physics we had not accessed before. The universe has surprised us before, and it will surprise us again. There are also the anomalies, the small deviations from expected behavior that accumulate in the data until they can no longer be ignored. A spacecraft might experience a slight, unexplained acceleration as it passes by a planet. A distant star might wobble in a way that suggests the presence of a planet, but with characteristics that do not fit the models of planetary formation. A signal might arrive from a direction where nothing bright enough to produce it should exist, based on our maps and catalogs. These are not dramatic. They do not announce themselves with fanfare, but they nag, persistent reminders that our models are incomplete, that the universe contains details we have not accounted for. Some of these anomalies resolve over time. Better data arrives, better instruments come online, and the mystery evaporates, replaced by a more complete understanding. The wobbling star was orbiting an unseen companion. The spacecraft's acceleration was a thermal effect, subtle but measurable. The signal came from a faint object we had simply missed in earlier surveys, but not all anomalies resolve so neatly. Some linger, resisting explanation, occupying a space between known and unknown that is both frustrating and fascinating. And then there are the silences, the places where we expect to find signals but do not. We have searched for signals from other civilizations, pointed our telescopes at stars we think might host habitable planets, listened across a wide range of frequencies for anything that might indicate deliberate transmission, and we have found nothing. No repeating patterns, no structured messages, no sign that anyone else is broadcasting into the dark. This silence is itself a kind of signal, a data point that tells us something, though what exactly it tells us is a matter of interpretation. Perhaps we are alone, or at least so isolated that no one else's signals reach us yet. Perhaps we are not listening in the right way, or at the right frequencies, or with instruments sensitive enough. Perhaps the silence is simply what the universe sounds like when no one is trying to talk. But the search continues because the universe is vast, and we have only begun to explore it. Every telescope we build, every frequency we monitor, every method we develop for detecting faint or distant signals expands the range of what we can hear. And as that range grows, so does the chance that we will encounter something that truly does not fit, something that forces us to expand our understanding not just of the universe, but of what is possible within it. These signals that do not fit are not proof of anything beyond what we already know. They are not messages, not yet, and perhaps not ever, but they are questions written in data posed by the universe itself. They remind us that the cosmos is not a solved puzzle, not a book we have read to the end. It is still revealing itself, still unfolding in ways that surprise and challenge us. And in that unfolding, there is always the chance, however small, that we will find something we did not expect, something that changes the way we think about the universe and our place in it. Perhaps these signals are the universe whispering in a language we have not decoded, hinting at processes or presences we have not imagined. Or perhaps they are simply noise, the random static that accompanies any act of listening when the signal is faint and the distances are vast. It may be that the distinction does not matter as much as the act of listening itself, the willingness to pay attention, to investigate, to remain open to the possibility that the universe still has more to say. For most of history, the conversation was one-sided. The universe spoke, in light and gravity and the slow turning of celestial objects, and we listened as best we could, with eyes and minds that strained to make sense of what they were seeing. But the universe did not hear us. We were silent, at least in any way that might travel beyond our world. We watched the stars, but the stars did not watch us. We asked questions, but the questions stayed local, trapped in the atmosphere of a single small planet. That changed slowly and then suddenly over the last century. We learned to send signals, not just sound and light, but structured transmissions, radio waves that carried patterns, information, intentionality. At first, these were local, meant for each other, messages bouncing from one place on Earth to another. But radio waves do not stop at the atmosphere. They leak into space, spreading outward at the speed of light, carrying with them an unintended announcement. Here is something that makes patterns, something that organizes signals, something that might be aware. We have been leaking for decades now. Old television broadcasts, military radar, the chatter of communication satellites, all of it bleeding into the void. None of it was meant as a message to the cosmos, but it is a message nonetheless, a signal that Earth is not quiet, that something on its surface is manipulating electromagnetic fields in deliberate and complex ways. If anyone is listening, if there are instruments out there sensitive enough and turned in the right direction, they might catch that faint wash of noise and recognize it for what it is. The signature of technology, the mark of a civilization that has learned to speak in radio. And then we went further. We sent deliberate messages, crafted with care, aimed at targets we thought might be worth addressing. One of the most famous was sent from a radio telescope in the 1970s. A short string of ones and zeros beamed toward a cluster of stars tens of thousands of light years away. The message contained a simple picture, numbers, chemical formulas, a representation of the solar system and the structure of DNA. It was symbolic more than practical. The cluster is so far away that any reply would not arrive for tens of thousands of years, long after the civilization that sent it has changed beyond recognition or disappeared entirely. But it was a gesture, a way of saying, we are here, we are aware, we are looking. We also sent physical messages, objects that carry information beyond the reach of radio. The Voyager spacecraft, launched in the 1970s, each carry a golden record, a disc engraved with sounds and images selected to represent Earth. Music and greetings in many languages, the sound of wind and waves, photographs of people and places, and the structures we build. These spacecraft are now beyond the outer planets, drifting into interstellar space, and they will continue for millions of years, silent ambassadors carrying the story of a world that, by the time anyone finds them, will likely be unrecognizable or gone. But sending is only half of the conversation. The other half is listening, and we have become very good at that. We have built telescopes that span continents, linked together to form apertures larger than any single instrument could achieve. We have sent instruments into space, above the distorting effects of the atmosphere, where they can catch wavelengths that do not reach the ground. We have automated the search, built software that sifts through vast amounts of data looking for patterns, for signals that stand out from the noise, for anything that might indicate a deliberate transmission. We have not found anything yet. The search has been going on for decades, and the silence remains unbroken. There have been a few false alarms, signals that seemed promising at first but turned out to be interference, terrestrial sources, or natural astrophysical phenomena. None have repeated, none have shown the kind of structure that would clearly indicate artificiality. But the search continues, because the absence of evidence is not evidence of absence. The universe is vast, and we have only sampled a tiny fraction of it, listening to a narrow set of frequencies for a brief span of time. If there are others out there, they might be using methods we have not thought to monitor, or they might simply be so far away that their signals have not reached us yet. What makes this search compelling is not just the possibility of finding something, but what it says about us. To search is to admit that we are not the center, that the universe does not exist solely for our benefit, that there might be others out there, equally aware, equally curious, equally capable of looking up and wondering. It is an act of humility and also an act of hope. It says that the universe is not just a place of objects and forces, but potentially a place of minds, of perspectives, of conversations that might span light years and centuries, but are conversations nonetheless. And even if we never hear a reply, even if we remain alone in the cosmic dark, the act of listening changes us. It requires patience, attention, the willingness to sit with uncertainty and keep searching anyway. It requires building tools and learning to interpret the signals they catch, distinguishing the meaningful from the random, the deliberate from the accidental. It requires us to think carefully about what we would say if we had the chance, how we would represent ourselves, what we would choose to emphasize or omit in a message that might be the only impression of us that ever reaches beyond this world. There is also a strange intimacy to the act of observation. When we point a telescope at a distant star, we are not just gathering data. We are attending to something, giving it our time and focus, acknowledging its existence. The star does not know we are watching, does not change its behavior because we have turned our instruments toward it. But the watching matters. It means that the star is no longer just an object in the sky, but something we have noticed, something we are trying to understand. And in that effort, there is a kind of connection, a bridge built out of attention and curiosity. We whisper back not with certainty, but with questions. We send out signals and build our instruments and train them on the dark, and in doing so, we say to the universe, if there is anyone there, we are listening. If there is anything to hear, we are trying. We do not know if the universe cares, if it notices, if our small efforts register in any meaningful way against the vastness and indifference of space. But we do it anyway because the alternative is silence, is passivity, is the abdication of the curiosity that defines us. And so we continue. We launch new missions, build new telescopes, refine our methods, expand the range of frequencies and the sensitivity of our detectors. We train new generations of scientists and engineers to carry on the search, to add their efforts to the growing archive of observations and data. We whisper back into the dark, not knowing if anyone will hear, but hoping that the act of trying is itself meaningful, a way of affirming that we are here, that we are aware, that we are part of the vast and mysterious conversation the universe has been conducting with itself since the beginning. It is late now, and the sky is very dark. The kind of dark that only comes far from cities, far from the glow of streetlights and the haze of human activity. Here, the stars are not suggestions, but presences, thick and layered, the Milky Way a river of faint light that arcs across the whole of the visible dome. It is easy in a place like this to feel small, to stand beneath so much vastness and wonder what any of it means, whether the universe notices us at all, whether our small lives and smaller concerns register in any way against the scale of everything. But perhaps smallness is not the same as insignificance. Perhaps to be small is simply to be particular, to occupy a specific place in the web of connections and signals and responses that the cosmos has been weaving since the beginning. We are not the center, but we are part of it, made from the same processes that made the stars, the same elements forged in ancient fires, the same quantum flickers that hum beneath the surface of empty space. We are the universe aware of itself, looking back at its own history written in starlight and whispers. The cosmos does not speak our language, but it speaks. It responds constantly in 1,000 subtle ways. It bends light around massive objects, leaves echoes of its own beginning in a faint and patient glow, sends ripples through space when something violent unfolds in the dark. It writes its presence in gravity and motion, in the timing of distant pulses, in the patterns we catch when we listen carefully enough. And now, in the last fraction of a second of cosmic time, something on a small planet has learned to listen, to decode, to whisper back. We do not know if the universe hears us. We do not know if our signals will ever reach anyone, if our messages will outlast us, if the conversation we have begun will ever include a reply from someone else, somewhere far away. But we have joined the conversation nonetheless. We have stopped being purely passive receivers and become, however faintly, participants, and that changes the relationship. It means that the universe is not something we only observe, but something we engage with, something we are part of, something that includes our questions and our curiosity as part of its unfolding. So perhaps the night does know our name, not because it calls us individually, but because we have written ourselves into its story. We have turned our attention upward, built instruments to catch the faintest signals, spent lifetimes decoding the messages that arrive in light and gravity and the hum of the void. We have added our own signals to the mix, sent out our own whispers, left our mark however small in the electromagnetic wash that now includes the signature of Earth. The universe is richer for that, not because we matter on a cosmic scale, but because we add something that was not there before: awareness, intention, the willingness to listen and to respond. And if you have stayed with this story, if you have followed the echoes and the starlight and the quiet background whispers, then you too are part of the listening. You have joined those who choose to pay attention, who wonder what the cosmos is saying, who are willing to sit with the mystery and the uncertainty and the slow unfolding of understanding. The universe speaks whether we listen or not, but the listening, when it happens, is what transforms silence into conversation, transforms distance into connection, transforms the vast and indifferent dark into something that might, just might, whisper back. The sky bends low, and something in it remembers. We are the question it has been asking all along.